Welcome to the video lecture on Matrix Algebra Part II. In a previous lecture, we learned how to add, subtract, and multiply matrices if the dimensions were appropriate. In this section, we learn how to divide matrices. The procedure in division of matrices is to multiply by the inverse of the matrix in the same way that we solve the equation 4x is equal to 12 by dividing both sides by 4, or equivalently multiplying both sides by the reciprocal 1/4. Before finding the inverse of a matrix, we have to identify something called the identity matrix, which plays the same role in matrix multiplication as 1 does for ordinary multiplication of numbers. There's something called the identity property of multiplication, which says that 1 times a equals a times 1, and that equals to a for any number a. Well, the identity matrix, which we use I sub n as the symbol for, is an n by n matrix for which each main diagonal entry is 1 and all other entries are 0. So I sub 2 would be the 2 by 2 matrix that has 1s along the diagonal and 0s everywhere else. I sub 3 would be the 3 by 3 matrix with 1s along the diagonal and 0s everywhere else. I sub 4 is the 4 by 4 matrix with 1s along the diagonal and 0s everywhere else, etc. Now, identity matrices behave like the number 1 in the sense that if you take the identity matrix times a matrix A, you'll get back A, and if you take a matrix A times the identity matrix, you'll get back A. So it's like you're multiplying that A, that matrix A, times 1 and getting back the original matrix A. So let's see an example. Here's my matrix A right here. This is a 2-row, 4-column matrix, so it's a 2 by 4 matrix, and we're multiplying it by I sub 2, which is a 2 by 2 matrix. Remember, when you do matrix multiplication, these two inner dimensions here, the number of columns in the first matrix has to equal the number of rows in your second matrix. And since these do match, our resulting matrix will be a 2 by 4 matrix over here. Now, the way that you get this is by taking the first row times the first column, and we do the first element in the first row times the first element in the first column plus the second element in the first row times the second element in the first column. So 1 times 1 would be 1, plus 0 times negative 1 will go to 0. So this is just 1 plus 0, so it stays 1. Now what we are going to do is, still using row 1 because we're filling out this row 1 over here in our answer, now we're going to multiply row 1 by column 2, and that'll get me this second column first row element over here. So again, we do first times first plus second times second. So 1 times 2 is 2, plus 0 is going to keep this 2. Then what we do is we stay in row 1 because we're not finished yet. Now we're going to multiply it by column 3. First times first plus second times second. So 1 times 4 is 4, plus a 0, this is going to stay 4. And then finally, to finish out row 1, we're going to take row 1 times column 4, first times first plus second times second, gives me 1 times 1, which is 1, plus a 0, so this stays 1. Now we've finished out row 1 over here, so what we're going to do next is move to row 2 of our identity matrix, and we're going to go back to column 1 of our matrix A. And we're going to do first times first plus second times second. So this time we get 0 times 1 is 0, plus 1 times negative 1, this is going to stay negative 1. Then we move to column 2, still using row 2. 0 times 2 is 0, plus 1 times 0 is 0, so this is going to be 0. Then we move to column 3. 0 times 4 is 0, plus 1 times 2 is 2. And finally, if we go to column 4, 0 times 1 is 0, 1 times negative 3 is negative 3. And hopefully you can see here that our final answer right here is exactly the same as what we started with for matrix A. So we took I sub n, or in this case actually it was I sub 2, so it was a 2 by 2 matrix, times A, and we got back A. So multiplying by an identity matrix has the same effect as multiplying a number by 1. It doesn't change your original matrix at all. Okay, if A and B are n by n matrices, and if A times B is equal to B times A, and that equals the inverse matrix, the identity matrix, then A and B are said to be inverses of each other. So if you have two matrices that multiply to this kind of 1 value over here, then that means the original two matrices must be inverses of each other. They kind of undo each other to get back to that identity matrix. The concept of the inverse of a matrix is very similar to that idea of a reciprocal of a number. So what we're going to talk about next is how to find an inverse of a matrix, assuming that it has one, because not every matrix will have an inverse, and we'll see some examples of that. So the first thing that we're going to do, it's a 3-step process, is we're going to create a new matrix that has this form to it right here. It's going to be a fairly large matrix. On the left, you're going to have exactly what matrix A is. Then you're going to draw this vertical line, and then on the right, you're going to form the identity n by n matrix. So 1's along the diagonal and 0's for all the rest of the elements. Then what we're going to do is we're going to transform the matrix A on the left into reduced row echelon form. In other words, we're turning matrix A into the identity matrix. So doing all of our various elementary row operations on this matrix A to turn it into reduced row echelon form so that it has 1's along the diagonal and 0's everywhere else. And what that does is it creates a new matrix over here on the right side, which is now called our inverse matrix. And the notation that we use for it is A with this little -1. So let's try one of these out. So here's our matrix. This is our matrix A. And what we're going to do to create to find our inverse is we're going to create a new, much larger matrix that has this matrix on the left, and then the identity matrix on the right. So 1's along the diagonal, 0's everywhere else. And then what we want to do here is we want to try to use our elementary row operations on this side to try to turn this into 1's along the diagonal and 0's everywhere else. In other words, we want to turn this left side into reduced row echelon form. So normally what we like to do in that case is we like to get a 1 first in that upper left corner. Unfortunately, there's no 1 already in this first column, and it doesn't seem very easy or obvious how to get that 1. This entire row is not divisible by 2, so that wouldn't work. This row down here is not divisible by 4, so I couldn't do that. So it's kind of hard to see how to get the 1. But hopefully you can see that it's not too difficult to see how to get a 0 below down here in this lower left corner, because if you have 2 up here, we could multiply that row 1 by -2, the opposite of 2, and add that result to row 2. In other words, what we're going to do is multiply this entire top row by -2, so this will become -4, +6, -2, 0, and that will cancel out the 4 that's down below when we add down. So that's the first thing I'm going to do. Since it's a little bit easier to see how to get the 0, I'm going to get my 0 first. Now I want that 0 down here in the bottom, so let's put our answer in the bottom row. -4 plus 4 will be 0. 6 plus -7 is -1, -2 plus 0 is -2, 0 plus 1 is 1, and I'm going to keep the original top row before we multiplied through by that -2. So now I have the 0 that I was looking for. I want next to see if I can get a 1 in this bottom right corner over here, and that is easy to do because it's just a -1. So all I need to do is multiply this row 2 by -1, and that will get me that 1 in that bottom right corner. So this becomes 0, +1, +2, -1, and I'm still not doing anything to that top row yet. Okay, the next thing that I'm going to do is I'm going to try and get this to be a 0, which I should easily be able to do since I have this 1 down below. So it's kind of like our normal process of getting zeros. You just take the row that has the 1, in this case row 2, and we want to multiply by the opposite of the number we're trying to get rid of. And I want to get rid of this -3, so I'm going to multiply by +3 and add that result back into row 1. So if we multiply this bottom row by 3, this will stay 0. This becomes 3, this becomes 6, and this becomes -3. And what we're going to do is add that answer into row 1. Remember, we're trying to get reduced row echelon form. So that means we need all the zeros above the diagonal as well as below the diagonal. We already have the 0 below the diagonal. Now what I'm trying to do is get the 0 above the diagonal. I still don't have that 1 in that upper left corner, but we'll get to that in a minute. So if I keep the original row 2, because that has the 0 and the 1 that I want to keep, and if I add the answer and put it in row 1, 0 plus 2 stays 2, 3 plus -3 is now 0, 6 plus 1 is 7, and -3 plus 0 is -3. So now I have my 2 zeros, I have one of my 1s. The only other thing I need for reduced row echelon form is to make this 2 into a 1. And I'm saving that for the very last step because the only way to make that happen would be to divide row 1 by 2, which is going to result in some fractions over here. So that's why I was doing that last, because I wanted to avoid having to deal with any fractions until the last possible moment. So I am going to take this whole row 1 and divide by 2. So this becomes 1, 0, this becomes 7 halves, and this becomes -3 halves. And then my bottom row is 0, 1, 2, -1. So if you know that you're going to have to deal with some fractions, try to keep that last step of dividing by the number that's going to give you fractions until your very last step, if possible. So this is now our identity matrix, a 2 by 2 identity matrix. So that means what's over here is our A inverse. So this is our inverse matrix, and it is 7 halves, -3 halves, 2, and -1. Okay? All right, now we're going to do this next one on our calculator, only because it's slightly bigger. It's now a 3 by 3 matrix, but you could still do the same exact process that we did before. What you would need to do is recopy this matrix on the left, and then you would put the 3 by 3 identity matrix over here on the right. So 1's along the diagonal, 0's below, and 0's above. And then you'd have to go and convert this into reduced row echelon form on the left side. And that's a little tedious to do, as you know, with 3 by 3 matrices. So we're going to do this on our calculator. And the first thing we're going to need to do is create a matrix to represent this matrix A. So if we pull up the calculator, remember we're going to go to this matrix button and just do second matrix, and we need to edit. And I'm going to go ahead and hit enter, and this is going to edit matrix A. Now I have some old numbers in here, but the original matrix A is this one that we see right here. So that's what we want to be typing in, and notice that it's a 3 by 3 matrix. So I want to be typing in that 3 by 3 matrix. So my dimensions should be 3 by 3, and then my elements were 1, -2, -4, 2, -3, -6, -3, 6, and 15. Okay, so there's my matrix A, And now what I want to do to get the inverse, it's very simple. You're just going to go back to your home screen. So let's quit out of here. So second mode to quit. And then we're going to, from our home screen, go back to that matrix button. But this time I want to use the name of matrix A. So here we don't need to arrow over or anything. We want exactly what's in matrix A. So I'm just going to hit enter. And I should now see matrix A typed into my home screen. And we want A inverse, which was that little -1 exponent. So all we have to do is use this x to the -1 button, and you'll get that A inverse symbol. And if we hit enter, here's what it looks like. Now notice that you do get some decimals here. And those are pretty recognizable decimals, so you probably know what they are. But if they were a little bit messier, or if you just didn't want to remember what they were, you can easily convert these to their fraction form by going to math. So click on math, and frac is that first command, so just hit enter. And this is going to turn that matrix into its fractional form. So hit enter, and there is our solution for our inverse matrix. Okay, so let me copy that down. So A inverse turned out to be -3, 2, 0, -4, 1, -2/3, 1, 0, 1/3. So very, very easy to do on your calculator, but you should still know how to do simple cases by hand as well. All right, let's try another example, and we're going to do it both ways. Since this is just a 2 by 2, we're going to do it by hand and also on our calculator. So let's start by hand by recopying this matrix on the left, and then creating on the right side that 2 by 2 identity matrix. So one's along the diagonal, 0 below, 0 above, and we want to do reduced row echelon form. So luckily I already have that 1 in that upper left corner. So now I'm going to try to get the 0 down below, and to do that I can just take the row that has the 1 in it, multiply by the opposite of what I'm trying to get rid of. So I want to multiply by 3, and then I'm going to add that result to row 2. So this would become a 3, -6, 3, 0, and we're adding down. So keeping the row with the 1, and the answer goes in row 2. 3 plus -3 is 0, -6 plus 6 is 0, 3 plus 0 is 3, 0 plus 1 is 1. Now in this one, what you should notice is that I have zeros down here in the bottom position. So there is no way that we can make this second column position right here become a 1, because the only way to do that would be to divide by whatever this number is, and you can't divide by 0. So this is the bad news. Whenever you get 2 zeros down here and it's not able to get a 1 in that bottom right corner, then that means that no inverse will exist. So that's what you want to look for. Zeros all the way across that bottom row. And if you get that, then that means no inverse exists. So let's see what the calculator would show us. We clear out of here. So we need to go back to our matrix, and we're going to edit matrix A again. This time it was a 2 by 2 matrix, and the elements were 1, -2, -3, and 6. So once you have it entered in, then you're going to quit and go back to that home screen, and then you're going to go back to matrix and access matrix A by just clicking enter, and then you hit that -1 button. Whoops, too many times there. And then we just hit enter, and here's what you'll see. So when no inverse exists, it's called singular. It's a singular matrix, and that's what this error is saying. So we have a singular matrix, which means no inverse exists. So if you see an error message like this, that's how you know that there's no inverse. So I'm just going to go ahead and quit, And let's go back to the next problem. Okay, in a previous lecture we learned that a system of equations could be written as a matrix equation. And we've learned how to solve systems using matrices. You did that back in intermediate algebra, but we also talked about how to actually create a matrix equation. So here's what we did. We took all the coefficients, and that was our first matrix over here called matrix A. Then we created a column matrix over here that represented our three variables, x, y, and z. And then we created our matrix B over here, which was all the constants that come on the right side of our equation. And because of the way that matrix multiplication works, we would take this entire row times this column here, first times first, second times second, third times third, and that becomes equal to 4. And that's how we get this first equation up here. So 1 times x minus 3y plus 3z is equal to 4. And then you would do the same thing with row 2, and that's this second equation, and then do the same thing with row 3. This row times this column, and that has to equal this 0. So that's why this matrix equation works, because of how we do matrix multiplication. So matrix A was called the coefficient matrix, X was our variable matrix, and B were those constants. So if we think about this as a matrix equation, like AX equals to B, what would we want to do to both sides here to solve for X? Well, normally we would want to divide by A, but that's the same as doing the inverse of A when we talk about matrices. So what we're going to do is we're going to solve this equation by multiplying each side by the inverse of A, assuming that it exists. So here's what it would look like. So if we start with AX equals to B, then what I'm going to do it to both sides to keep the equation equal. I'm going to multiply both sides on the left by this inverse matrix, A inverse. And we're doing it to both sides, so it's still keeping the equation equivalent. Then just using the associative property, I'm just shifting these parentheses so that they are now around the A inverse times A, and I'm going to go ahead and multiply those two matrices together first. And that's just your associative property. Because A inverse is the matrix of A, or is the inverse of matrix A, these two cancel each other out into that identity matrix. And remember, an identity matrix times any other matrix X always gives you back that original X. It's kind of like that identity property of multiplication. This is like taking 1 times X, it's going to give you back X. So what we end up with is that X is just A inverse B. So let's go ahead and do this for this problem up here. So what we're going to do is we're going to first need to type in matrix A into our original matrix category on our calculator. Let me copy it down here so that I can see it a little bit better. And what we're going to do, remember that the solution to this equation, this is the key part right here, the x, y, and the z, the variables, are whatever you get when you multiply A inverse times B. So we also are going to need to know what matrix B is, and matrix B is that column matrix with just those numbers that were on the right side of the equation over here. Okay, so we know what A is, we know what B is. Now to find out what the solution X is, we are going to first need to figure out what A inverse is, and then we need to do A inverse times B, and that will be my solution. And we're just going to use our calculator to help us out on this. So the first thing I'm going to do is I'm going to go to my matrix button, and I'm going to edit matrix A and type in what it is, and this is a 3 by 3. So that should be my matrix A. Now I'm going to go back to matrix, and this time I'm going to edit matrix B, because we need to know what those numbers are on the right-hand side of the equations. So go ahead and edit B. You have to arrow down to B first. And this has 3 rows, but it only has 1 column. So 4, -11, and 0. Okay, now into my home screen again. So go back and quit out of here. First, we need to figure out what our inverse matrix turns out to be. So from your home screen, go back to matrix, access matrix A, so just hit enter, and then we need to use that little -1 exponent to figure out what the inverse matrix is. So there it is. If you want it in that fraction form, which I prefer because it just looks cleaner, I'm going to use that frac button, and that way we can see it a little bit more clearly. So there's A inverse. Now remember, the solution to our system, the values of x, y, and z, are going to be what A inverse times B is, because that's what we had to do to cancel out that A. We had to multiply both sides by A inverse, so that means we had to multiply this B on the right-hand side by A inverse as well. And we can do that on our calculator. So what we're going to do is we're going to take this A inverse, which I now have in my screen here, and I'm just going to take that answer. So use this ANS button that you have right above your little negative, and we're going to multiply it by matrix B. Use that multiplication symbol. Otherwise the calculator won't know that you're trying to multiply matrices here. So we're going to take our last answer, which was A inverse, and now I want to multiply it by matrix B. So go to matrix, arrow down to B, hit enter, and now hit enter again. And this is what we end up with. 1, 2, 3. So let's write all this stuff down and figure out what it means. So A inverse turned out to be this matrix: 3, 1, -4, 7/3, 2/3, -11/3, 5/3, 1/3, and -7/3. Definitely not a matrix that you would want to have to figure out by hand because of all those fractions to deal with. Then remember our solution, which is this matrix X, which is X, Y, Z, that column, is A inverse times matrix B. And what we ended up with was 1, 2, 3. So what that means is that X is 1, Y is 2, and Z is 3. So our solution, X is 1, Y is 2, Z is 3, or if you want to write it out as an order triple, the order triple 1, 2, 3. Okay, our last example here, just another one just like what we did. So the first thing we want to do is rewrite this as a matrix equation. So we need to transform these linear equation, or these systems of equations, into a matrix form. So your coefficient matrix, which is that matrix A, would be X is first, Y is second, Z is third. So this top equation has a coefficient of 1 for X, 1 for Y, and there's no Z. Then the second equation has -1, 3, 4, and the third equation has no X, a 4 for Y, and a 3 for Z. And what we're going to multiply that is this variable matrix, which is always X on top, Y in the middle, Z on the bottom. And that's because you would take this entire row times this entire column. So 1X plus 1Y plus no Z's equals our B. And the B is these 3 numbers over on this side. So 3, -3, and 2. And if you were to verify and take this row times this column and set it equal to 3, you should get back this first equation. Second row times this column equal to -3 should be your second equation. and third row times this column equal to 2 is your third equation. So now what we know all of our things are, what we need to figure out is what is A inverse, and it should still be a 3 by 3 matrix, and then we need to take A inverse times B, and that is going to equal our x, which should be this x, y, z. So if we do that on our calculators, it should be very easy to do as long as you know how to set everything up correctly. So let's pull out the calculator, and we're going to need to edit this so that we type in matrix A, then we're going to find its inverse, edit matrix B, and then multiply the two together. Alright, so let's go to matrix, and I'm going to edit matrix A. It's a 3 by 3, and it had 1, 1, 0, -1, 3, and 4, and 0, 4, 3. Okay, let's go ahead and edit matrix B. So go over to edit, down to B. It's also a 3 by 1, so I don't have to change my dimensions, but this time the numbers on the right were 3, -3, and 2. Alright, let's go to our home screen. First we need to find that A inverse. So we're going to do second matrix and get matrix A, and I'm going to raise it to the -1 to figure out what its inverse is, and if you want that in fraction form, you can do that. So there's matrix A, or the inverse of matrix A, and then what we do to get our answer for x, y, and z is we take this inverse times the b. So we're going to take this answer using that little ANS command down here above your little minus sign. So second negative to get that ANS, and we're going to multiply that by matrix B. So hit matrix, arrow down to number 2 for B, and hit enter. And there is x. X is 1, y is 2, z is -3. Very, very simple to do on your calculator as long as you know the steps to take. So let's just write it down and then we're done. Okay, so just for reference, the inverse matrix A was 7/4, 3/4, -1, -3/4, -3/4, 1, and then 1, 1, -1. And when we multiplied that by B, we got 1, 2, -2. So that means x is 1, y is 2, and z is -2. So our solution is 1, 2, -2. Alright, that concludes our lecture on Matrix Algebra Part 2.